Okay, and a good morning, not just a morning, but a good morning to everyone. And that was...
Bare Trees, Fleetwood Mac.
Okay, it was Fleetwood Mac, okay, with Bare Trees. Pass that to me, please, Robert. Thank you. And the, I guess, main topic for this week is that we have an exam. And I want to bring some attention to that. We had a quiz on our tutorial day, and I have not graded it, waiting for that to get finished. And as I've looked at it being handed in, it suggests that not as ready as I'd like for the test. I did take time on Friday to outline what we're going to be doing on the test, I believe it was. And so I've written up the test at this point, and based on some of the concerns I have and what I had wanted to do on Friday, which was cover 5.2, and we did, but with less than a full class, it's a little bit too dicey trying to include that. So what I've done is I wrote up the test. I've restricted it to chapters 3 and 4. Went up through 4, 5. I've got 20 questions in the test. The quiz I gave you on Friday is very well represented on the test. Now, I've mentioned to you that you're supposed to have done, at the end of last week, 5.1. That was just a review of fractions. That was open for you. And based on the decision I made about the test, I decided not to open up 5.2 and 5.3 until yesterday. So I opened up 5.2 and 5.3 yesterday for solutions. I'd like to talk about that, but I'd like to at least outline for you how I've written the test, what I have done. Bless you. The test goes back to 3.3. I believe it is. And so I've gone from 3.3 to 4.5. I opened up the book and I looked at 2 problems roughly from each section. Took a medium level and one a little bit harder than that. Wrote my version of the problem and continued doing that until I got up through 4.5. That means you are going to have a couple word problems to deal with. But with 20 questions, you can still do very well in the test, even if you're having trouble with that. But as you prepare for the test, what you should be doing is going back, look at each section. Just pick a problem, 2 problems from each of the sections. And for everything except, I think it's 4.4 and 4.5, I believe I was working with expressions or equations. I wasn't doing word problems. So I expect you to be able to do the mechanics that are involved. So if we look at a problem such as solving an equation, then you would expect to see an easy one and a little more difficult one. And we had sections where you had, when you simplified, you expected to see something like x on one side and a number on the other. Then there was a more difficult problem where you would have maybe 3x on one side and a number on the other, and you had to divide by 3. So that kind of subtlety will be addressed in the exam. So you will need to be preparing for that test for Wednesday. And yes, Wednesday, this Wednesday. And so today I'm going to spend more time in 5.2. Tomorrow I'm going to spend more time on 5.3. And then you'll have the test on Thursday. I will be doing the tutorial on that. And then we're going to show you how that's set up for you. And this is a little different arrangement than it's been in previous weeks. But I'll bring this up on the document cam here in just a moment. And this is, I think, Debbie, part of the solution to what Palomar was having problems with for the week. And that's why it is done this way. Let me bring this over and scroll down. This is the week at a glance for this week. Okay, and the first thing as we go to there, you'll see that we have 5-2, simplifying fractions. And one of the things that I'm concerned about as I set that up, as we come off there for a moment, the work we did Friday was focusing on the problems that have variables in it, not reducing fractions that are arithmetic. And when you look at the homework assignment that's done in the computerized version, it's focusing on the entire chapter or that section content and not doing enough with the simplification. So I'm going to make a hand-in assignment due tomorrow, separate from the computer part, from your book, and I'll be doing that also in 5-3. And I'll get that on the board momentarily. But as we come back to the document cam, and I go down a little bit further, you'll note the next section is 5-3. I'll talk about that in a moment. And then, of course, we have the test, and then the tutorial, and then new work on Friday, which will be in 5-4. So my goal is to go ahead, have the test Wednesday, cover the solutions to the test on Thursday, and cover new material in 5-4. And we will not have a quiz as such. Missing the tutorial day this week is going to put you at a great disadvantage. In fact, for those of you who missed Friday, I have a very simple expectation. You go over to the library at the reserve desk and you watch the lecture. It's that simple. You can do that anytime you miss a Friday, and that's probably one of the best things that I could ask you to do. So you have some time you owe me, and if you are going to have to be absent this coming Friday because of the obligations you have, then you are expected to make up that time watching the lectures in the library on the VHS tape. Now, in terms of 5-2, and by the way, we used a blue book the last test, correct? Get another blue book for this test. Don't recycle the old one, or a green book. And it should be the small one, not the big one. Well, let me go to 5-2 for just a moment and indicate to you in both 5-2 and 5-3 how I'm going to do the homework there that I want turned in as a handed-in set of problems. The section that we're talking about is on page 342. And give me a moment, Debbie, to get this sort of lined up, because I'd like to block out certain part of it temporarily. Okay, just to give you an idea. This is on page 314, and it starts with problem 41. Okay, and you'll note that there are variables involved. Okay, I want the problem written, I want an intermediate step, and I want a solution. As we come off there for a moment, that's 41 through 52, all. So as I go to the board on that, this is on page, again, 314. First few digits of pi. So number 41 through 52, all. Due tomorrow. Okay. Write the problem. Two, show an intermediate step. At least one. And you have your solution. Done neatly. Okay. And there are 11 problems there, and as I mentioned, we won't have a quiz per se, but I'm going to count these two assignments as a quiz grade. So this is in section 5.2. Then, in section 5.3, just looking ahead so you have an idea of what's happening there. In 5.3, the focus again doesn't start occurring until problem 43 in this area again. Okay, so that's page 329. And that starts with problem, we said, number 43. And that goes through 66. All. So let's see, that means we have 12 and we have 24. It means about 3 dozen problems that you're going to have due for those 2 days. This one is due tomorrow. This one will be due on Thursday. Okay, so these are the homework assignments in addition to what's on the computer. So you have, these are set up on the computer for you. And that material on the computer does involve some of the arithmetic we've done in the past in a Math 10. This is all the new material on this. And as I say, this will be done with these 2 sections by Thursday. And then Friday, we go into 5.4. Is there any question on that? Okay, the test itself, again, remember, is on sections 3.3 through 4.5. And same basic direction on the test that I have on the homework. You're going to write down the problem except for a word problem. You're going to write down the original problem, intermediate steps, and solution. Any question in any of that? Okay. Bomaro, you had a question. No, I'm doing 5.2. I'm going to discuss 5.2 and maybe start 5.3. We did 5.2, but my concern is with so many people not here, when I tried to do 5.2, I'm a little bit reluctant just to go on in a kind of cold-hearted way and say, you're on your own. So we'll spend some time on it. Yes, Isaac.
So we have a test on Wednesday. Can you just briefly do 3.3 to 4.5?
No, I suggest you go back and watch the VHS tape and what we talked about. No, I'm not going to do that. That's what it's called studying and preparing for a test is about. So that I'm assuming you're going to do maybe 2-3 hours prior to the test. You are expected to make that kind of commitment. I know, but you're going to have to find time. Jobs and that I know get into the way, and so the only thing I can suggest is, since we have tonight and tomorrow night, that gives you 2 days to do that, and hopefully you might have been doing some of that over the weekend.
Yes.
I know, that's why being here on Friday would have been so nice. Richie?
What's the test on? Like what?
3.3 through 4.5.
3 what?
3. 3.3, section 3 of chapter 3 up through section 5 of chapter 4. 3.3 through 4.5. Reference your text. Okay, now let's get back to some of the problems in 5.2. I'm just going to write my own version of one of these so that I don't end up doing a problem for you and discuss what kinds of things that we talked about and how you deal with it. I introduced the idea of a negative exponent from what we'd done in Math 10. I think it bears repeating. So let's just have some fun as I go to the board. We want expressions that involve variables. So I'm going to use this space here. So let's say I have something like a negative 35, and I have x to the 4th, y to the 3rd, and I have it over 15, and I have x to the 2nd, and I have y to the 5th. Now that's a pretty straightforward problem without too many wrinkles. And the part here where you're reducing this fraction, you could do with primes. We talked about that. Or you can do it in the usual canceling that you've done in the past. You see a 5 common to both of them. Robert?
When it's an improper fraction like that, can the end result be a mixed number?
Okay, good question. It's an improper fraction. Do I work with a mixed number? No. In a very simple way. No. Assertively, no. You don't want a mixed number when you have a product involved. And that goes back to when we multiplied with a mixed number, we changed it to an improper fraction. But a good question. So I'm going to do this part in the sense of just taking a 3 there, a 7 up here. So I know I'm going to have negative, and this is understood to be a positive here, so this will be a negative 7. Okay, and by the way, are all the quizzes now turned back in? Just pass it up here on the side. If you could. Shamra, could you just be kind enough to pass that up? Okay. You can hit him on the top of the head afterwards. Negative 7. Now, if I have x to the 4th over x squared, I recall on Friday what we had done before. We said if you have a to the m, a to the n, you subtract the exponents. So you have this. Now, the difficulty here is that when we did this before, the exponent on the numerator was a larger number than the exponent in the denominator. Here, it seems to work okay, because I'd have an x to the 4 minus 2. That works. But if I do this one and subtract the same way, I end up with a negative exponent. And as a rule, when we think of this particular result, we don't make a restriction. We just learn to interpret our result. Now, remember, this is going to be negative 7, x to the 2nd, y to the minus 2. If I were just to take a look at this portion, I understand that that becomes y times y times y over y times y times y times y times y. And this becomes ridiculous if the exponents get large. But we can sit there and cancel the factors that are alike. And I find that this is 1 over y squared. Because of that, I make a definition. So I say as part of my definition that I want to understand this result I get here must mean this. Now, it's just simply a definition. It says how we're going to interpret negative 2 as an exponent. It says you're going to take 1 over that variable to the positive exponent. There are a couple things that are very critical here. One, the negative exponent does not make your result negative. It just tells you that the variable's in the denominator with a positive exponent. That's all it says. So this is a perfectly acceptable way of writing the answer. In the text and on the computer, you will be asked to write your answers with positive exponents. So if you get this, you need to understand that it can be rewritten as negative 7 x squared, and then you just put it over y to the 2nd. Because this part is the same as 1 over y squared. So if I multiplied that first part times 1 over y squared, I get this. Bomaro. Well, I left the 3 out for some reason. Thank you. I ignored it is the phrase, I guess. So that was a good question. Let me first. You have a choice. You can put it over 3 that way, or just over under the 7. Now I would have negative 7 x squared over 3 y squared. And thank you. Appreciate that. Michael.
It could also be written as negative 7 over 3x squared y squared.
You couldn't have the x squared in the denominator.
You because it's a...
It would have to be x to the minus 2 in the denominator.
Shouldn't be negative 2. Why is it 2? Why is it?
Which part are you asking about, Richie? I lost your question.
It's right there, negative 7x to the square and y negative 2.
Correct.
Okay, then how come it's not negative on the bottom of 36?
Because I now have it in the bottom in the denominator.
Trading your negative for 1.
I'll try to answer your question showing you a different way of looking at it. You have negative 7x squared over 3 times 1 over y squared, because y to the minus 2 means 1 over y squared. I'm just breaking this apart now and saying I have this as a monomial, if you will, times this factor, and that could be rewritten this way. And then when you multiply, you'll get what we have down here. Is that answering the question or not? Okay, the temperature does not have, I hope, anything to do with the understanding. But, okay, well, I could say cool it and try again. You want to go back to it again, or? Again, I had 7x squared by subtracting the 5 from the 3. That was y to the minus 2. I can break this into two pieces. Now, this means 1 over y squared. That's by our agreement. Just an agreement, a definition. Y to the minus 2 will be interpreted, for no reason particularly, as 1 over y squared. When I do that and multiply, I get the 3y squared down here, and I get the negative 7x squared up here. And I'm going to let that go for the moment. Hopefully, in a few more minutes, it may ring a bell better. Let's try another one. I want to make sure I don't make things too hard. Let me come back center for a moment and see how badly... Yeah, we can have 3 variables. So I'll go to 3 variables in a moment. Before I do that...
Okay, so if the...
Okay, let me go back to the problem. Okay.
Let's say the x to the 4th was on the bottom and x squared was on the top, then the x variable would be in the numerator part of the...
If you had, otherwise what Michael's asking, if this had just been flipped, x to the 2nd in the top, x to the 4th in the bottom, then I would have had x to the minus 2, y to the minus 2, and I would have had x squared, y squared in the denominator. Make sense?
Yes.
Ask for the positive.
If I ask for the answer to be written so that
But I could have had,
it is with a positive exponent, this is the way you would write it, but if not, you could write it this way.
and then it's just, like you said, it would just be negative 7x to the negative 6.
Yeah, had we done what Michael had suggested. Isaac,
I was curious, do you have to show all that stuff? Because you actually can do it just looking at it.
I want an intermediate step. This is the intermediate step. I know you can look at it and do it in your head. I think it's dangerous. I think you get more out of it the intermediate step, so I will not give full credit without the intermediate step. I'm hoping that by asking that, it'll stay with you better. If I don't think you do as well later. Let me go to another problem. This time, let's try 3 variables. Negative 18x y to the 7th z over, and I think I'll take that to the 3rd, over a 27, and I think I'll make that a negative, make this x to the 5th, y to the 4th, z. Do the numerical part, what's called the coefficient, numerical coefficient, first. So what is our sign going to be? Positive or negative when we get done?
Positive.
Okay, it's going to be positive. And if I divide negative 9 into here, I'll get 2, negative 2. Oh, rephrase that. If I divide negative 9 into this, it'll be positive 2. Negative 9 into here, 3. So we do get the 2/3 Robert was talking about. Now, what do you have to be careful of here? Before you hit the negatives. Okay, the exponents and the variables, I agree. So what are we going to do because we're extra cautious? Yes, Isaac, you're 1. I would prefer to put these 1s in. It's so easy to just overlook them. If you put the 1s in, I think you'll have fewer problems. Now, I'm not obligating you to put in those 1s. But if you miss the problem because of it, I think it would be unfortunate. I would like to see you just do what I'm doing here, subtract the exponents. I'll let you look. If I'm blocking your view, take a look at one of the monitors. We've got 3 of them in here that you can see. Jessica.
Can I automatically, just because I know it's going to be a negative number times, automatically put x 5 minus 5?
I want to see the intermediate steps.
I know, but I'm going to put, like, instead of putting all the variables, I mean all the...
What I've done there is intermediate step is what I want to see.
I just put the 5.
I know what you're telling me. I'm telling you what I want to see. Okay? I want this intermediate step. Now the next part, where you have 2x to the minus 4, y to the third, z to the second over 3, would be a result of what you could do starting in the original problem and bypassing the intermediate step. Now, in the computer, what form will you be expected to do? Richie, if you just look right behind you, about 3 feet away, you can see very nicely what I have on the board if I'm blocking your view. Okay? But now what I'm going to do is write 2 y to the third, z to the second, over 3 x to the fourth, because that is with positive exponents, and that's the way you want it in the computer. Is there any question there? We okay with that? Let me just walk out of the way. Bill Morrow.
I put that in the computer, but it said it's wrong. You have to put the multiplications in between the y and z.
Okay, this gets to do with how it has to be entered into the computer. What multiplication symbol is being used in the computer? A dot? Okay. So if we go back to that for a moment, Debbie, Bill Morrow's telling me that you would be expected to have, would you have to have a dot after the 2?
No.
So you can have 2, then a y to the third, and then a dot with z to the second? Okay. That's all if it's if it's not accepting it without the dot, put the dot. You do not have to put the dot on your test or in any homework that you would do for me. It's understood when these two are written together that you're going to multiply, and the dot seems to me a bit anal. But if that's what's necessary for the computer for right now, let's accept it. James?
Can you do a problem with just numbers?
Just numbers.
Numbers.
Just like...
Intermediate step. It has to be intermediate step for just numbers.
Okay, let me see. I'm going to come back to center and see if I can get an idea what kind of problem that you might like. Something like
10x or 8x over 32.
with no exponents?
No.
Okay. Let me go to the sideboard here, Debbie. I'm not sure what I'm going to be doing here, but I think what is being asked for let me see if I can get a problem up here with flattening out this soft cover book, which I continue to be frustrated about. Now the problem that you're asking is something very similar to what's here in the book where we have 10x over 32. Something like that. I won't do that one, but let's see what we can do. So let's say I end up with 75 yz over 15. And there's a question, how would I expect an intermediate step there? first thought, I understand why you're asking the question, because what you might be held accountable for in a test. You can also be reasonably assured you won't find a problem that easy on the test. So to some extent, it's a moot point. Ideally, if I had something like this, I'd really expect you to do something like 3 to the first dot for multiplication there for Bolmaro. 5 squared y to the first z to the first over 3 to the first dot 5 to the first, and force you into prime factoring, where this is 3 now to the 1 minus 1, 5 to the 2 minus 1, y to the first z to the first, and 3 to the 1 minus 1 is 3 to the 0, so that's 1 times 5 to the first, y to the first, z to the first, which if you put it in the computer probably would be 5yz. Now, I would present something like that trying to emphasize the prime factoring that we did in Math 10. And I agree on a test, it doesn't make sense to ask for that amount of tedium. And I should be satisfied with you just saying, gee, 15 into 75 goes 5, nothing else happens, and you're done.
That sounds good to me.
Yeah, I thought it would be. So to the extent that if I gave you something that straightforward in a test, there's no real need for an intermediate step. But for the problems we did in the board just now, the intermediate step is reasonable. I will try to give you problems such that an intermediate step is desirable, reasonable, and maybe to your advantage to use. Okay? Any other questions regarding this kind of problem? Now you remember the problems, and I'm going to make this a little bit of a moment of going back to the 7th review in a Math 10 where we said reduce with prime factors. I'd like to put something in perspective there. So reduce using primes. Now this comes home to me because we just did our midterm in Math 10 today. And for the midterm in Math 10, we have a problem where it says reduce using primes. So if I did something like that and I had a 48 and I had it over a, let's say, 72, then I would expect, using prime factoring, that you would go ahead and write this as 2 times 2 times 2 times 2. There's your 16, times your 3, over, and then this is 2 times 2 times 2 times 3 times 3. Now what I'm doing there is understanding 72 is 9 times 8. 8 is 2 times 2 times 2. The 9 was 3 times 3. This is 16 times 3, and 16 is 2 times 2 times 2 times 2. And then I expected this to be done in the Math 10, putting the 1s where you had canceled, and you get your answer of 2/3. Now what I want you to understand is that this would make a whole lot more sense by writing 48 as 2 to the 4th times 3 to the 1st, and writing the 72 as 2 to the 2nd times 3 2 to the 3rd, thank you, times 3 to the 2nd. I'd already gone to the 2nd in my head with the 3, and what I think I write too often. This would then be 2 to the 4 minus 3, 3 to the 1 minus 2, which then becomes 2 to the 1st, 3 to the minus 1, which is the same as 2 over 1 times 1 over 3 to the 1st, which is 2 over 3. Now, I'm reasonably convinced that you see that last bit of work as excessive. But in terms of what we are doing in 5.2, it should make immediate sense as an alternative. And so there's a certain effort to take numbers and understand what you're doing with numbers and say, well, I'll do the same thing with letters as variables. I hope you see the similarity between this problem, and as we slide over for a moment, Debbie, to here, that you see the similarity there to what we did in the front board as Debbie goes to the right side there where we had our 2y to the third z to the second over 3x to the fourth, as she brings that in with camera 1. Thank you, Debbie. Now, what we've got there is just a variation on what I have here in the sideboard. They're all doing the problem in the same way. Part of what I'm coming back to Isaac's question, how much do I have to show? My obligation to you is that when you walk out of this class successfully, that you go into an algebra class and you do well. Now, I find that if you don't write out steps at this point and really get them grooved in, your memory isn't going to last as long, and you've got a complication involved here to the extent that the obvious next step is a 70. You've got a summer session ahead of you, and unless you walk into a summer session with Math 70, you have to keep in your head a year's work for 15 weeks. Okay? I can tell you what will happen in those 15 weeks if you don't do any additional work.
There's a summer session in JC?
You will have an empty head at the end. Now, if you do the summer session, be cautious because it's 5 hours. That means 4 hours of lecture a day, 7 hours of homework a day. That's 11 hours a day expected 4 days a week without doing any prep for an exam. It is very intense. Okay? So when I'm doing my 2 stat classes, they also are 5 hours. I tell my students that if you're thinking in terms of 4 days a week with 11 hours a day being expected, that's a full-time job. And that may be the demand. Now, you can try getting by without doing the homework. Generally speaking, students don't make it. You have a test a week, and in 5 weeks you're done. Now, if you don't do that, then you need to do something on a weekly basis, reviewing what we've been doing and trying to get to the point where you can keep it in your head for what amounts to a full semester before you come back in the fall. So, Debbie, I'm going to go back to center. So bring camera 1 back over to center, if you would. I'll leave this in the board, and I'll come back to the front because I want to see how this differs from 5.3. So I'm going to make a small transition to 5.3. I'm a little bit hesitant here because the feedback from Sarah, she's one section ahead of me, is that 5.3 went with a little more difficulty. I have a suspicion it might, but here's a problem on page 322. Okay, now I'm going to bring that down a little bit tighter. That'll work. And then I'm going to write that on the board and talk about it because this is at a complication level much greater than what we're doing in 5.2. Let me first write. I need the parentheses a little bit larger than I started to write there to provide room. So let me try again. And then once I get this written, Debbie will come back. Okay, this is the simple version. This is where it first starts. And this is to the third power on the outside. So let me talk about this a little bit. This fits into the classification of a new rule. Now, I've already mentioned to you that we said if we had a to the m over a to the n, this is a to the m minus n. This problem that we're looking at now is a to the m to the n. So that would tell me that I write this base, a to the m, n times in a product. So I could say, if I had, as an example, before I get to the problem we had there, if I had x squared to the third power, this means I'm going to have x to the second times x to the second times x to the second. Well, since I'm multiplying, I would add these 2's together and get x to the 6th. Well, the shortcut is just to say you have 3 times 2, hence x to the 6th immediately. You have to also understand that if I have a, b to the m, that is going to be a to the m, b to the m. So if I had, with this as an example, x, y, all to the third, it's going to be x to the third, y to the third. Then we put that together. So let's say that I had, before I get to this problem, x to the second, y to the first, all to the third. Then that means that I have x to the second to the third, y to the first to the third, which is x to the sixth, y to the third. You can think of multiplying this exponent through to simplify. Marisol?
How do you tell the difference when you multiply the
We're-
3 and the 2 as say that it's
As opposed to adding.
times 2?
No, I didn't anticipate that. Say that again.
Like, you know how when you do that kind of stuff, there's the one where you go 3 times 2, and then there's the one where you say you do times 2 3 times. So it's 2 times 2 times 2, which would be 8, not 6. How do you know the difference?
You're talking about the difference between maybe 2 to the third power, which means you multiply 2 times 2 times 2, which gives you 8, as opposed to, say I have 5 squared to the third power, where I just multiply these two together and get 5 to the sixth. Part of that answer is involved with the base. Otherwise, when I had 2 to the third, it was writing the base 3 times. So if you want to look at it in that way, if I have 5 to the second to the third, I could say, well, do the same thing. Write the base, 5 squared, 3 times. Now, because I'm multiplying with the common base, I end up adding those exponents, not multiplying 2 times 2 times 2. Now, I'm not sure if that's providing the clarification you want, but that's my effort to answer it. So you sort of put all this garbage together, all these little pieces, and I come back to my original problem, which was a negative 2 with Isaac's 1. That's a real critical one here. Then the x to the second, then I'm very careful to write 5 to the first, y to the first, all to the third. Because, man, there's so many things happening here. First, Debbie, just that much. A, B, quantity to the m was a to the m, b to the m, correct? If I had a over b to the m, then it would be a to the m over b to the m. With all that said, with all those little pieces, you're supposed to understand that this then becomes negative. And by the way, since I have a 3 here, a negative here, that's 3 negative factors. So I'm just going to have a negative immediately. Then 2 to the third, x to the sixth, 5 to the third, y to the third, and I'm done. Now, sometimes you're expected with small numbers to say, well, that can be rewritten as negative 8x to the sixth over 125 y to the third. And the question, how small do you have to have a number before you play that hand? Well, if I had 13 to the third, there's no way I'd do it. 2s, 3s, 5s, and you have exponents of 2, 3, 4, reasonable. There comes a point of common sense here where it's hard to give you an absolute rule. Now, in a math 70, where Sarah was doing this particular type of problem, this is part of our table talk at dinner, talking about problems, and one of the students, she had in a 70, was grumbling because there was no particular rule for when you do this versus leaving it this way, and wanted something in concrete about when you must do it. Well, in doubt, do it. But if I give you something like, say, 11 to the 8th power, and you're ambitious enough to multiply 11 times 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 11, go for it. Okay? Leaving that on the board for a moment.
So it's on your own discretion.
Okay, your own discretion, but much as they say as a basic speed limit in California, drive as conditions demand. And you say, well, the speed limit was 70. The fact that it was a hailstorm with a 100-mile-an-hour wind and you were doing 70 probably will get you a ticket, because the conditions are such that would be dangerous behavior. So do so at your own discretion and be ready to pay the fine. Robert. Catch you first. Bomaro. I'm getting over towards there. 31 on page 328. Okay. Before I do that, I'd like to go one of my problems, and then I'll come back to yours. I'm surprised a little bit that you asked for that one, but let's see what we can do here that's... Now, understand what we're doing with that one problem. If you'll look at the... Not quite yet, Debbie. I need to get the answers blocked. But let's look at this one. Okay. This is all the way down to 65, where we find the problem of the type we just talked about. So clearly this is not what? It's not your bread and butter. There are problems that are a lot easier than this. But if you were to do this one, you understand as we look at it. And since it's one you're doing for homework, I don't want to carry it too far. But because the exponent up here is a 4, that means the sign of your resulting answer will be positive. Now, what are you going to write in here to keep from making a foolish mistake?
1.
Into the first, 3 to the first. Okay? Now, we get into a question here. I'm going to write a problem similar to this, but with a little bit of difference, because I don't want to do a problem for you that you have to do. So I'm going to take a minus, and I'm going to take an m to the second, and I'm going to leave this as an n, and I'm going to put this over 5, and I'm going to put a letter p, and I'm going to take it to the third, and I'm going to take all this to the 5th power. Now the question, what's the sign at the end? It's going to be negative because I have 5 factors, each a negative. So I know that right out of the gate. Now the question, does it pay to write m to the second to the 5th, or say that's m to the 10th? This is a 1 understood, so that's n to the 5th. This is a 1 understood, so this is 5 to the 5th, and a p, and here's where, getting back to Marisol's question, you have to be very careful. I'm going to get an eraser here. But when you do this, there's a real temptation to go ahead and see this 3 and this 5 and not multiply. You think, like p to the 3rd times p to the 5th, and where you'd add the exponents, but you multiply and you get this. Well, hopefully it wouldn't, but I've seen enough papers where people just pull something in their head that says, gee, I should add these exponents. Now, when they're close like this, not a problem. But they get further apart and strange things happen. And again, I'm going to ask why we do the silly things that we do. If I'm thinking of another number in my head, I've already gone from part of it to a new exponent. As you saw, I wrote the exponent I was thinking instead of what should have been written. How many times have we done things putting the cereal box in the fridge? You've never done that? You just haven't lived. Or the milk in the cabinet. Or you crack the egg, the yolk goes down, and you put the shells in the batter, and just because your mind is totally distracted on mathematics problems. We do strange things. If you have not yet done that, hats off to you. Okay? Or look at the green light of the other traffic, waiting for it to turn so you know when to get ready to take off. You see green, say, I got to go, and pull into traffic. Somewhere along the line, you've done something that qualifies as a silly mistake that causes you, hopefully, just minor embarrassment, not lethal consequences. How do you avoid that? Well, one way of doing that, perhaps, is to do this as an intermediate step. And again, I'm very concerned where we overstate this and you end up taking too long to do a problem that should be done quickly. So you have to hit the balance between showing steps and speeding things up. This may make it easier to get to here. Now what about the 5 to the 5th? Is that a reasonable one to work out?
Yeah.
I'd say marginal. 5 squared, 5 cubed, because we've done place values with base 5. Anything past 125, I'd opt out and say 5 to the 5th, that's good, leaving it as is. If you say, yeah, but 5 to the 4th is 625, multiplied by 5, you're at 3125, okay, but I wouldn't. Because there's a danger you'll do what? Make an error in the multiplication, and then I have to dock you. You didn't have to do it, but since you chose to do it well. Okay? Let's go back to the document cam for a moment.
Don't lose your negative sign.
What now?
Don't lose your negative.
Thank you. Well done. Okay, leaving that there. That's nice when you say that before we go off air and I come back and he says, why didn't you put a negative sign there? And I go, oops. Now, I had a question about earlier problems. I'm going to do one more just visual, and then what I want to do is come back to the question about number 31. This is number 52, sort of blocked out. And by the way, this is not a bad thing to do, to block them out a little bit so that you don't get bothered by the other garbage. Now, what are you going to do with this one? Well, first comment, you could just ignore that dot and just act like there was a line all the way across, because that's what you're going to get. If you do that, then you have a b to the 3rd over a b to the what? 1st, and you have a c to the 5th over c to the 3rd, and you can cancel the 5 into the 10, and the a to the 4th is all by its lonesome. I do want to see some intermediate steps there. Now, the question, as we come off there for a moment, Debbie, that I was asked to come back to is one that we'd done earlier, and just a reminder as we look at it. Now, I have not done much with estimates here in terms of what the text is asking you to do, but here is a mixed number. Now, if you're talking about the estimate part, which I assume was the question, the first factor at 3 1/5 is about 3. I dropped it down. Now round up the 1 3/4 to the nearest unit, and you get 2. So 3 times 2 is about 6. That's what I expect in my answer. So again, I'm bothered by the fact that I have a mixed number. But can't you just round each of these off to the nearest integer? 3/4 is more than a half. So I'd round the 1 up to a 2. The 1/5 is less than a half, so I'll round the 3 1/5 down to a 3, so 3 times 2 is 6. Then, to check my answer, I'm going to rewrite the first one as what? 16 over 5. Then I have 7 over 4. So if I look at that in terms of what I'm getting, and I'll take some of the pencils that Liliana so nicely brought in and rewrite that as 7 over 4, and as we slide that underneath, what would you then do? You'd cross-cancel the 4 and the 16, agreed? So you would have 28 over 5. Okay, 28 over 5, okay, is going to be what? Not 20, hold on, did I do that right? Yeah, 28 over 5, which is 5 3/5. So 5 3/5 becomes our answer. Is that about 6? Well, in the ballpark. If you round up, yes. Now, whether or not that helps you in the sense of estimating, I see it as sort of an artificial thing to some degree, yet I end up having to do that a great deal in a stat class. We'll come back more to this tomorrow. I am flat out of time, so Debbie, as we close down here,